fifth grade. I hope that this video finds you well. If I sound a little bit congested right now, it's because I've been keeping all of the windows open in my apartment so that it feels like I'm outside and a part of the world and being active. And that means that all of the pollen from the beautiful trees that are blooming outside has gotten into my home and then into my nasal passages, and because I have allergies, made me super congested. But I'm feeling great other than that. I have on my school sweatshirt. I have my water bottle with water for consistency. And I am so excited to get to teach you guys a little bit about rounding decimals today. Rounding decimals and decimal place value might be a thing that you're finding as you're working through those packets, and since it's been a really long time since we worked in that in school, you might have forgotten some things, which is totally fine. But thankfully you guys are all such engaged students and care so much about your education that you came to check out this video. So I'm really proud of you for doing that, and I'm super excited to get started. So let's go. Okay, so when dealing with place value and with rounding, the first thing that you have to know is what the different names for the different place values are. So here we have all of them written down, or not all of them, they go on forever, but at least the three that you're going to be encountering in your worksheets that you're going to be dealing with. So first is the tenths, then the hundredths, and then the thousandths. It's different than tens or hundreds or thousands. It has that little nths at the end, which makes you know that it's like the smaller one. It's the one that comes after the decimal point. And they kind of go in the natural progression that you're used to, but just flipped. So when you're looking at numbers, you think, okay, it goes 10 and then 100 and then 1,000. This is just the same thing going the opposite way. So we have a 0 here. This could be any number really, but I just put a 0 to make it the easiest and the simplest. Then we have our decimal point, and then after that we're going to put a number in the tenths place. We're going to put a 3. And right now we would read this number as 3/10. Going back to what we were working with converting fractions and decimals, it's quite obvious that it's 3/10 because you could write it as a fraction like this, and you know that it would be the same. So if it helps you to remember that, like, oh, this is literally 3/10 because it's equal to 3/10, that works awesome. The next number that we're going to put in the hundredths place is a 4. And so now, this number, we would read it as 34 hundredths, and it would be equal to 34/100. And then we're going to put a 6. So we would read this as 346 thousandths, or you could read it as 0.346. But in problems, because they really want you to have the terminology down, they might say it to you as 346 thousandths, and that's what this looks like. So that's important to know just in terms of when you're reading the problems, if it's asking you to have so many hundredths or so many tenths, just to know what that looks like numerically. Switching to this side with our number line, it's also important to know what these numbers mean, because when it's just numbers, it can be a little bit tricky to really like conceptualize it, but when we put it on a number line, it helps us really figure out like what this means in relation to other numbers that maybe we're more familiar with. So since it starts 0 point something, we know that it's a little bit more than 0. So here we have our 0, and here we have our 1 on our number line, and we know that it's going to be somewhere in between there. Then we can go, okay, so it's 0.3, so we go to the 3, and we know that it's between 3 and 4, but we want to get even more specific about where it is. That's why there's more numbers. That's why we have our hundredths. And we can look at this, and in between here I drew 10 lines. Really, there's 10 lines in between each of these. So in between 0 and 1, there's 10 lines, and then in between each of these little sections, there's an additional 10 lines. Think about when you're looking at a ruler, and you have all of the ones that represent centimeters, but then you also have the ones that represent like millimeters in between. That's exactly the same, because just like the metric system, our own number system is based off of tens. So if there's 10 lines in between each of these, if we were to count that all up, that would equal 100 lines. And that's another place that we're getting that hundredth from. I just drew it in between the 0.3 and the 0.4 because that's the numbers that we're working with, and I didn't want it to get all jumbled up. But so, okay, so we have 0.34. So if I count 1, 2, 3, 4, we know that it's about on this line. But it's even smaller, it's even more exact because it's 0.346. And so actually it's in between this little section, the 0.34 and the 0.35. Okay, so now if you can see this, what I did is I made a magnified version of just this little section of the number line. Kind of like in science, if you were to look at something under a microscope and you can see a little bit section of it way bigger. I took the area between the 0.3 and the 0.4 and I made it this whole thing, and I broke it up into 10 little sections. And then in between this 0.4 and this 0.5, I made it into 10 even smaller little sections. And if you look back to this one and you think if in between each of these 10 sections, there were 10 more sections, and in between those 10 sections, there were 10 more sections, that means that there would be 1,000 lines in between the 0 and the 1. And that's where we get thousandths from. So if we look here, our number is 0.346. We're already at the 0.3. 0.4, and then count up to 6 more little lines. And that's the most exact that our answer can be, right here. Now, you're probably starting to think, Mr. Like, I can't see that. That's like really small and really hard to see. And that's true. And sometimes it's not practical for us to work with numbers this small. And that's where rounding comes in and becomes super important. So when we're rounding a number, what we're really trying to do is find what number it's closest to. And so for instance, if a problem is asking you to round a number to the hundredths place, it means that it only wants 2 numbers after the decimal. It wants the last number that it's seeing to be the hundredth. If it's asking you to round something to the thousandths place, it means that it wants 3 numbers. It wants you to show the thousandth. Similar if it's asking you to round to the tenths place, it wants you to only have 1 number after the decimal point. So going back to the younger grades, I'm pretty confident that all of you have experienced rounding before. If you're rounding something to the hundredths place, it means that you're really going to look at the number in the thousandths place and see, is this number bigger than 5 or smaller than 5? Is 6 bigger than 5 or smaller than 5? I feel like I'm like Bear in the Big Blue House waiting for you guys to respond, but you're not going to, but it's bigger than 5. So that means that it bumps it up. It takes this number and it says, you're actually closer to a 5 than you are to a regular. If this number was smaller than a 5, then we would just not round up and we would just keep it as a 4, as 0.34. But since it's bigger, what we're going to do is we're going to round this to the hundredths place. And we're going to make this 0.35. Now that we have 0.35, we know that that's a simpler number to work with, and we don't even have to worry about this whole little section of our number line anymore, because it's just too specific and too difficult to deal with. So we can really just look at this one and see, oh, okay, so it's between 0.3 and 0.34, and actually, it's not even closest to 0.34, it's closest to 0.35. And so that's where it would be on our timeline. If we were to round this to just the tenths place, since there's a 4 after the 3, the number in the tenths place, and 4 is smaller than 5, we're not even going to worry about rounding that up. We would just keep it as 0.3. And so if we're just trying to round our number to the tenths place, it would be right here at 0.3. So that's kind of the general gist when it comes to rounding decimals and their place values. If you had a number that was, say, like 0.46 and it wanted it rounded to the tenths place, you would think, okay, so 6 is bigger than 5, and so that bumps up the 4, that bumps up the number in the tenths place, and that would actually be 0.5, and then that would go here. But yeah, so that's about it for today. If you guys have any trouble with this or with any other math things, you're always free to email me or Mr. Howes or Miss Nicole. We're here to help you, and we know that you guys are doing great work during this time. Remember to stay safe, wash your hands, especially if you're going outside or perhaps running to the grocery store or something with your parents. Keep working on all the great things that you're doing. We love seeing you guys at morning meeting, and I hope that you have a great day. Bye!